What's up, guys? Welcome to In Defense of Idan. Today I have a very fascinating interview for you where I sit down with software engineer Ben Kwan, who specializes in smart propulsion in the drone space. I really hope you enjoy this conversation as much as I did. Really looking forward to sharing some of Ben's very impactful and wise insights. As always, please like and subscribe, and let's jump right into it. So you didn't graduate school and jumped straight into the drone industry. I had the pleasure of knowing you when you were still at Lehigh, and through those years, you were always in different projects, not always drone related. But what kind of brought you to that space? What kind of got you excited about being a computer scientist in general when you were just starting up?
I am a cognitive science major, and I was really into my research project involving like faces and like first impressions and how it like affects like your judgment. But I went to like a career fair and handed out a bunch of resumes, and tried to get interviews from a lot of companies. Well, in the back of my head, still thinking like, oh, maybe I'll go to grad school and continue research. But I got a response from one company who was trying to hire to create. They wanted to create a new like software engineering team at their company, basically just developing like a web app or like a web-based system for one of their tools. And I was interested because I took some computer science classes already and was at the moment taking an Android class, and they were interested in making an Android app. So it kind of lined up, and I kind of took the risk and pivoted from research to software engineering. I just thought that it gave me like, a foot in the door. So ever since then, I've been developing software. But I wasn't always like really into drones at all. I like barely flew any drones like before working in the space. I just got the opportunity to work at like a cool startup, and they're involved in the drone propulsion space. So I just thought it was a really cool opportunity to work at any startup, and it just so happens to be in the drone space.
And I want to backtrack even earlier because I know that you used to be enrolled in robot camp, and eventually you used to be a counselor as well. So I want to kind of understand how that influenced your career decisions, and how you were in a STEM related after school program, and it really did impact the way that your career unfolded. So let's talk a little bit about how that impacted you.
Yeah, I started robotics in like the end of middle school. We had to do like sports and activities, and I wasn't the best at sports, so I can naturally gravitated to like robotics and like STEM related fields. So I was part of the Vex robotics team in high school, starting my freshman year, and we've had really great mentors, really great resources, and we were able to like really go far in our tournaments and competitions. I mean, I learned a lot along the way, especially from like the seniors. It was like a few opportunities where you got to like interact with like the upper class.
What was your favorite project?
Every game was different each year, so you had to kind of like you couldn't use the same robot every year. So it was cool coming up with different types of designs to play the game well. But towards the end of like each season, teams towards to gravitate towards one design, the design that tends to win more. But one year, my buddy and I decided to make just like go off meta, make a different type of like design. It was like a kind of scissor lift system, like super inefficient, super slow, like did everything like worse compared to the other design, but we just kept at it because we thought it was cool, like different. We weren't just copying pasting someone else's design. We got honestly further than I expected because you were still able to play like defensively and stuff, and our robot was really heavy, so it was hard to push around. But when you design robots to be like super fast and super quick, they have to be light, but that means they're easier to push around. So there are like pros and cons that you have to factor in when designing like a robot. So I was, super interested in that, and like just getting my hands dirty, building stuff. Like it's kind of like Legos, but like with metal and screws and motors. Yeah,
What was the game that that robot was designed to accomplish?
it was. This game was involving beanbags, and there were like collections of beanbags stacked in different areas of the field. And there was like in the middle between the two teams was like a trough. And basically, the team who puts the most beanbags in their trough wins. So you could play defense by like scooping beanbags out of their trough or like collecting a ton of your beanbags and putting in your trough. I thought that was a very interesting game. Like the bean bags as a game element is very different than the other years that I played, where it was just like a basketball shape or like a donut ring or like a cube. This was like a very like malleable bean bag.
So it sounds like, you're doing, those were the early days of robots that are pushing around items at warehouses.
Hmm.
You really, it does seem like applicable to what robots are doing today. Maybe, so if you would kind of invent a game for kids today, like what do you think is the most important mission for them to accomplish? Like what's the biggest need for young children that are getting involved in robotics for them to learn?
Um, I mean, what definitely continuing what the robotic programs that exist now, keeping those going. But I've been seeing a lot more newer programs added to like curriculums, like soft robotics or making underwater robots, robots that have to swim and navigate in like a swimming pool or something. So that adds like a new dimension to it. And maybe even like getting them started with like flying drones. Like they can really like gamify the flying experience when it comes to like FPV, for example. You can run simulators on your home computer, and then that could translate to like driving like a mini FPV drone that's like fairly cheap nowadays. And that's all like part of like helping their motor skills. And nowadays they're like better at video games than we are just because they're just better at handling the controllers, at least for me. So yeah, just the natural progression of STEM and STEM education is very promising.
Okay, so let's transition over to what you're doing today. So from your early days at the robotics camp to dealing with brushless motors on a drone. Um, and most people that have built a drone maybe will say that, these brushless motors are $30 components that you could order on AliExpress. They're really just plug and play, and you can get the necessary performance that you need from just about any supplier. So what would you say is different about the motors that you're dealing with?
There's definitely a very good use for cheap, easily accessible motors. Like if you are in a very like high intensive environment and you like crash your drone or something, you don't want to have to replace like a very expensive motor because you might not need all of the like crazy features that an expensive motor might offer. So like the type of motors that I deal with involve like integrated ESCs and high performant calculations that run in the motor to enable the motor to spin very efficiently. There's a lot of custom firmware that we can load onto like these motors to help them perform as optimal as possible in under different conditions. Whereas like a cheap motor that's like not as smart as the ones that I work on, they can overheat easily or they might not like spin in sync with the other motors as well. So all those little tiny factors may affect the performance of your drone, but whether or not that difference in performance affects like how the application for your drone is, up for discussion. You can have to like do it like a cost analysis to see if you really need smart motors versus like the cheaply dumb accessible motors.
Generally, would you say what spaces are going to be most benefited by having a smarter drone motor that's going to communicate back to the
Hmm.
flight controller and provide additional logs that the drone can then use to operate more efficiently and increase their performance overall?
Yeah, like these smart motors, like they're not cheap at all. They're like at least like twice the cost of like a regular motor. So I would assume like if you're willing to spend the money on these motors, you're putting it on a drone that is absolutely like reusable. Like it's not like a one and done type of drone. You want to be able to like send it off on like a project and then have it come back, you know, send it to somewhere where it's hard for humans to go to, like an abandoned mine shaft or like a chemical toxic environment, chemical spill or something. And then you can send it like a very expensive drone out there where you invest in these really high quality motors to ensure that the drone can safely, you know, go to its destination and return back while being able to hover in the air for an extended period of time to collect data. The smart motors are able to like send data back to like your motor controller. So you can basically like do a lot more calculations on the fly and get more telemetry from the environment to make decisions while out there.
So in a normal drone, you have the flight controller that gives a command to the ESC and then
Hmm.
controls the motor power, right?
Hmm.
So is it more of a feedback loop where more information is then being reverted back to the flight controller? Or are they independent items that are calculating their own efficiency and
Mm,
optimizing themselves?
that's a good question. There can be multiple feedback loops along the entire like chain of the motor. For example, your motor itself can have a loop like by adjusting its PID values. By setting certain parameters into the motor's firmware, you can have it adjust its PID values to quickly adjust its speed based on certain conditions.
Can you, for
Is
the audience, just clarify what PID?
all right, yeah, PID tuning, proportional, integral, derivative. It is a way to make the motor respond to the environment smoothly and in like kind of like stable manner, like um being able to like adjust its speed like in a smooth way to avoid like very like jerky actions or like unwanted actions that can cause your drone or your entire system to like flip and crash. That self-contained like PID loop is within the motor itself, but you can also always read that type of data, that telemetry from the motor in your flight controller. So then that's another like feedback loop between your flight controller and your motors. Your flight controller must on the fly calculate all the telemetry from all the individual motors at any given point and make decisions itself. So yeah, that's an example of like multiple different feedback loops to create like one continuous system.
I want to talk a little bit about propeller design because obviously that's the other component of the propulsion that's
Hmm.
in the majority of drones today. How important is it to have the right high-end propeller alongside these motors? Or does having these smart motors allow you to kind of discount the firmware, the hardware, because you have this software-enabled motor, you can spend less on the propeller, or is a high-end propeller just as important?
So having access to a smarter motor, a motor with, more capabilities would allow you to be able to tune it better. So when you have a motor, you can test different propellers on the motor. So whether it's on a drone or on a test stand, when you're testing like one individual propeller and motor combination individually, hook it up to a bunch of sensors and basically assess different types of propeller and propeller combinations with your motor. So you can see how a very high-end propeller performs with a very low-end propeller. But the cool thing about having these smart motors is that you can tune the parameters on the motor to make that combination as optimal as possible. So if your combination with the smart motor and a cheaper propeller fits the requirements of your entire drone, then you can get away with having a cheaper propeller.
Got it. So looking at, the way this software actually impacts the way the motors operate, talk to me a little bit about pulse width modulation and how the software, maybe at a high level, can impact the way these drones operate. Obviously, PWM can control the way these drones sound. Maybe some drones require stealth when they're flying. Other drones, maybe it's less of an importance. But how are these motors contributing to optimizing this for drones?
So, PWM, like pulse width modulation, is a very common way to send just like signals to another device. It allows like kind of like a analog like wave, and depending on like the width, you can send different like signals. There are many other different communication protocols that you can use, like CAN or like D-Shot, but PWM is a very common one where most motors can communicate using this protocol. Having like a smarter motor allows you to communicate with other different communication protocols, which have their own like pros and cons. So it depends on like what your system requires. And what's cool if about like a drone supporting multiple different communication protocols is that like if one line of communication gets cut, you can like fall back on another protocol that's like based on like another set of hardware that's connected between your flight controller and your motor.
Okay. I want to move on to another topic. I want to talk, you touched on this briefly, about the need for economic sense in the way that we build our drones, regardless of what industry or application is involved. I want to know if you're seeing at a high level a race to the bottom or a race to the top as far as drone quality is concerned. Is the name of the game high output, low value, and low quality, or high value drones with the highest quality will eventually win the day?
I guess I might be biased when it says like I am more, I guess, partial towards like high quality drones, which implies they would need like high quality motors and stuff. But those high quality drones probably have like the most benefit, like I guess, to society because they're like reusable. They have more applications to like our day-to-day life. Like for example, just like a drone delivery service. Like imagine if you can get like your food order via drone delivery. You don't want to have like cheap like one-time use drones for that application. But that could totally like, change like our lifestyle when we have like another form of transportation for like goods and services. The future definitely lies, in my opinion, in high quality, expensive drones. And eventually, as tech gets cheaper, those drones should get cheaper to manufacture.
Fact that we're able to put this cutting edge technology in the hands of the average consumer, just for a pretty uh, reasonable price, has been a trend in the drone industry that has created more fans of the hobby. It made it more accessible to more people, and also has been a big reason why I think we are seeing more and more drones being used in different applications. Time will tell, I guess, when which industries are really going to invest in those custom drones that, won't have that aren't built off of normal platforms and require additional enhancement in order to complete their missions. So as far as the impacts of these cutting edge systems, one thing I want to talk about is the autonomy, necessarily at AI play, what you're involved in, the additional, sensors and the additional logs that are being fed from the motor to the rest of the system definitely gives you an opportunity to maybe even override commands from the pilot. So if the pilot makes an error, maybe these smart motors know even better than a regular motor to override such commands and make their own decisions. Where do you feel this ethical consideration as a software developer comes into play? Is it something that you are considering when you're developing these systems, or are you more leaving it to the customer to fine tune when these overrides can occur?
Tough question to answer. Obviously, we definitely want to design tools that benefit society, and uh, I honestly don't work a lot with like AI or like edge AI, since having like a whole AI system on like an embedded system is like it's really hard. There's like a lack of space. The chips aren't like capable of like really, at least for me, for what I do, running these AI systems. But if you're talking about like implementing like AI systems on the drone itself, if the drone can support like the hardware to run it these systems locally, I might lean towards more just like machine learning where you have all these sensors come together and react to the environment, having machine learning algorithms make decisions when the line of communication is disconnected between the operator and the drone. If the drone can make its own like informed decisions through machine learning, I feel like that would be a cool way to like kind of rescue your drone, like keep your drone from like doing something unwanted, like a failsafe. But that all depends on whether or not your hardware can support um these AI systems, machine learning systems.
And would you say that the future of drone operations, maybe you're operating one drone or multiple, which is where we're seeing the industry gravitate towards. Do you see humans having that standard pilot responsibility in this technology stack, or do you feel like eventually they'll become high-level mission commanders where they're just giving general guidelines of what they want the drone to do and leave the rest up to the system to decide?
Well, currently there are a lot of like regulations against with like just flying drones in the public. You have to have like licenses, and you can't fly in certain airspaces because they're blocked off, or you'll get in like serious trouble. We don't see swarms of self-driving cars on the roads, and that leads to the same ethical like dilemma where like who's responsible when something goes wrong. Like if a self-driving car has an accident, like who's at fault? The way it is now, you still need a driver in the car. The driver, you know assuming they're following like all the safety guidelines and stuff, like should be aware of the situation and try his best to like stop it. So the way I see it, there still requires like a human operator for drones, and like someone responsible for making the decisions for where the drone needs to go.
Okay. So there's different levels of automation. Usually there's a 0 to 5 scale where anywhere from zero automation to human in the loop to no human in the loop, which is eventually the high level goal of a lot of automation robotics companies. Do you think that level 5 automation is around the corner? Or do you think that, the regulatory environment along with the missions that we need these drones to complete will always keep humans somewhat in control?
I don't think it's around the corner, considering like the state of just AI coding tools at the moment. Like they're definitely like very useful, but they still like often make mistakes, and can't solve really like nuanced like problems by themselves yet. So I think like having a physical drone be able to be fully self-autonomous is still like a ways away. And I still think that we would push towards having a human in the loop, being able to know when something goes wrong, um, is very valuable.
So I want to talk to you a little bit about what's currently holding the drone industry back from making that next step into the future of the industry. Currently, there's a couple breakthroughs that maybe the drone industry is waiting on in order to really make that next step, whether it's the power supply on the drone, whether it's the edge AI that the drone can compute on the drone itself. Maybe it's a material science issue, getting that weight down on the drone so they can make deliveries, for example. What do you think is the most important thing for drone engineers to solve in the coming years?
I think you're in the right direction when it comes to the power. How literally just like how much power you can supply to your drone to support like continuous flight. I'm pretty sure like, having a drone that can fly like 30 or 40 minutes is very good. Like it's really hard to have a full drone like have continuous flight for an extended period of time. Um and everything that you have to factor in when designing a drone comes down to like how much you can like stretch your battery. So you want to make it like very light, being able to power all your sensors for the entire duration. All of that like, cuts into your flight time. So if we can find like, better power sources, better batteries, then we can extend the continuous flight time of the drones and have it perform like longer projects, longer missions, and essentially just gather more data at any given point.
If I can give you $100 to invest in the top solid state battery startup or the top hydrogen cell startup that will eventually be used to power your next drone that you build, how much of that money are you giving to each one? Are you going all in on one play, or are you still unsure who's going to be the one that, brings this solution?
That's really hard to say. Yeah, you can't really tell until you see like a real like, consumer application that implements these like sustainable solid state like batteries. Who knows, maybe in the future like some nuclear power source would be available. And if that's the case, all in on that, right?
And you're in on nuclear drones with nuclear reactors. I
Nuclear
think
cell phones.
so. They each present their own challenge. With solid state batteries, I believe it's the price that is a huge restrictive element there, and then with hydrogen cells, it's getting it stable enough to house it on a moving vehicle. So I really hope that one of these breakthroughs come through in the near future, because just adding additional battery cells to whether it's a car or a drone, is only as it's only as efficient as the weight, right? So
Yeah, it's like
we-
definitely diminishing returns because your weight just shoots up and your drone can't fly. Doesn't matter how many batteries you have on it.
let's talk a little bit about where you see the drone industry going in the very distant future. Let's talk 50 years, okay? I want to know what you think drones will look like, and specifically, do you think they will still be using rotating propellers within Earth's atmosphere?
I'm always hesitant when I'm like near them, just because like they can easily just like slice through your hand or something. So if they could find a way to like kind of like make them safe to be around, encase them in a way, that'd be really cool. I'm seeing like a lot of drones of different sizes, from like drones that are like the size of like cars, capable of carrying like a full human. So I'm sure we'll see like way more drones of different sizes and drones of different like designs. They're like vertical takeoff drones where it doesn't need like a runway to like fly. There are like there's fixed wing drones where you kind of like require like a runway to get started, but then it'll just like glide along the air without much use of the propellers when it starts gliding. So I'm sure we'll see all sorts of different designs for drones, and drones that require like less hardware to maneuver the same efficiently. For example, like having like propellers being able to do different like pitches without the use of extra motors would be very useful, kind of like an underactuated propeller movement. So reducing the cost of like hardware and the number of like hardware required while being able to move freely through the air would be like a really cool like drone design in the future. So yeah, I'm excited to see like all the different sorts of like drone designs.
It's funny you bring up vertical launching drones and the dangers of propellers. One of the premier startups that is supposed to be changing the way the United States Army operates. They were testing their VBAT vertical launched. Did you hear about this? The vertical launch VBAT drone, and it required at the time one service member to kind of grab it while it's about to hit the ground and kind of like position it correctly. And he like severed one of his fingers, and it was a huge issue as this contractor was trying to showcase their technology and win those defense contracts. So maybe it's great advice to put a lot of R&D into getting rid of propellers, less in the industry, and more more fingers on our hands.
For sure. That's insane.
I'd like to ask you also, where do you think the future of drones is more dependent on? Do you think that physics or code will be more important?
With better materials, like materials that are can last longer under high, like stressful conditions, will definitely be beneficial to the drones. Like having propellers that, don't crack under pressure, or like having a better way to cool your motors to keep them at a optimal temperature for an extended period of time better, and will all make the performance of your entire drone system better. And when it comes to software, like it's constantly changing, always improving. I'd say like, yeah, having better physical properties of the drone, like material design, material science, being able to manufacture these high quality like materials better, um, and more efficiently, like maybe like 3D printing like the entire drone will definitely help, you know, um, make the drone industry a lot better.
You mentioned that so getting these drones lightweight, more maneuverable is going to be huge, and maybe in the same way that we're shrinking the amount of compute needed to run these large language models and machine learning models on our drones. Maybe we can compensate for the fact that we have limitations on the battery output that we can use to run the edge AI is just directly from. Do you think that as these models get smaller and smaller, is it going to become more feasible to have these autonomous drones work in a more expected way that's more sustainable?
I mean, yeah, it seems like the next trajectory of the development of like AI and stuff, being able to run these AI models on smaller chips and having it more accessible. So I feel like it's only natural that as that progresses, we'll see more and more, I guess, but yeah, potentially drones with like eye on them. Uh,
I'm looking forward to seeing drones the size of insects, autonomously zipping around my city and hopefully not spying on me. But it's scary that these things are going to get smaller and smaller.
yeah, yeah. That is a scary thought. Can't imagine what these tiny drones would do.
Let's wrap up with just one final question. For someone getting into drones now, um, and someone that is interested in, doing a project at home or getting into the industry, what is your best advice that you can give them?
Just like any tinkerer, just grab a cheap kit and dive into building the drone yourself and trying to program it yourself. Like, buy a flight controller, buy some cheap motors to hook it up to, cheap drone body, and then download some, open source firmware like PX4, and then try to, use open source software like Q Ground Control, RG Pilot or something to mess around and really try to make your drone fly. And yeah, the best way to learn is just get your hands dirty.
Awesome. All right, Ben, thanks so much for joining. Really appreciate it.
Of course, glad to be here.